here we go. So after you have it factored, if you're actually finding the zeros, bless you, you're still finding the x values. So my x values would be at 7 and negative 5, but we would want to write them as x-intercepts as 7, 0, negative 5, 0. So when it says to find the zeros, really that means your y value should be 0 because you're finding an x-intercept. So it doesn't mean you're really solving the problem any differently. It's just your answer gets written a little differently. Another question that you'd like to go over?
40?
40? Okay. 40? Okay. So number 40, you're making a square frame of uniform width for a square picture that has the lengths of 2 feet. So you've got a 2-foot picture, 2 feet by 2 feet. And you want to make a nice frame that goes around it. And the total area of that frame should be 5 square feet. And that's this shaded area. So that shaded dark area there, that total area should be 5 square feet. So what is the length of the sides of the frame going to be in order for us to have a 5 square foot frame? So when you're thinking about this problem, we have the area of the frame. Verbally, like, what would you have to do to find the area of the frame? No, sorry, Nina.
Do x plus 2 times x plus 2.
So, but what would you be looking at with the picture to try and get the area of the frame?
Length times width.
Length times width. So we need length times width. But what part of it is the area of the frame? Is the whole thing the area of the frame? The black part. So how would I find just this region here? What would we have to do just to find that region of the black part? Brandon?
Can we find the area of the white part and then find the area of the black part and then subtract the area of the black part from the white?
Okay, so we would need the area of the picture, and that's this part right here. So right here, I'm really good at drawing. There's my little stick figure.
It looks like you.
Oh,
This.
No, it looks more like you.
So that's our picture. If I take this piece out of the problem or take it away and put it out of my picture, then I have the frame left over. So we need to take the total area of the whole entire piece, and if I subtract the area of a picture, then whatever's left should be the area of the frame. So you've got the whole entire piece, the frame, including the picture. It takes up a nice big space on your wall. But if I just want to deal with how much my frame should be, I need to take that entire area and subtract the area of the picture so that I have that extra piece left. So the area of the frame is 5 square feet. They tell us that area of the frame. The total area of the frame should be 5 square feet. Nina said that the area is length times width. Well, what's the length of the entire frame? Or the entire piece of artwork, whatever it happens to be. Brandon, what's that length? X. So the entire length is x. And if it's length times width, I really have x times x, or x squared.
Is that a square? Yes, it is. It looks like a square on our papers, but it doesn't.
It is a square, yes. Up here, oh, you know what? It doesn't, yeah.
X and X.
That's because my board is
But it looks
not
like
a
a
square.
rectangle.
Yeah, it's distorting the.
I'm not sure, Mary.
And then how big is the picture? What's the area of the picture? 4, because it's 2 by 2, or 4. So you have the area of the frame, that's equal to the entire piece that you have hanging, minus the picture part. Whatever's left should be my frame. So if I set this equal to 0, I end up with x squared minus 9. And Cooper, how would x squared minus 9 factor?
X plus 3 and X minus 3?
Yeah, it's a difference of 2 squares, difference of perfect squares, perfect square, binomial, whatever you want to call it. So that means one answer is negative 3, which we know we can't have because we can't have a negative value. The other answer is positive 3,
So x equals 3.
so x is positive 3.
And the length.
So the length and the width should be 3 feet, which means that your frame it's a 1 foot frame, which that's a pretty big frame to have a 1 foot frame bordering your 2 by 2 foot picture.
2 foot
Yeah.
picture's a pretty big picture. It's
Questions?
like this big.
Are there any other questions? Yeah, 2 foot picture is a pretty big picture. 24 inches.
2 foot, yeah.
That's a nice size
It's like
picture.
that big.
Like that. This is a huge frame,
It's like this big.
Brandon.
It's like the size of the phone.
Why couldn't they just go to the store and just pick
It's
up
like
and
almost
just
as
like
tall as
have the picture and the reference to see which one fits?
I mean,
we
you
have
could.
to solve their problem.
Because they're making their own frame.
Why do we have to solve their problems?
Jordan's huge.
Figure it out.
All right, so I'd like you to please place your homework on the side of your desk. I have a tiny little quiz on factoring. Should be easy peasy.
Chelsea, do you have
Been to your house so many times.
Chelsea, my study coming on is water's telling me.
Count your dog.
Of course.
Here, dog. What's up, dog? What do mind like with me?
Oh.
Miss King, we need one more.
Need another one?
Do you have to like find, do you have to like put it to 0 in?
So all you're doing is factoring. There's nothing else that you're doing with the problem. You're not solving. It's 6 period.
6, thank you.
When you're done, if you can turn in your packet to page 19 and start the couple of warm-up problems. If you're done with the quiz, you can turn it in the brown bin on my desk, and then if you please open your packet to page 19.
I'm guessing it's the
not
only
brown.
bin. But it's the only bin.
There's not another bin, so I'm gonna go with that. I've thoroughly.
If you're colorblind enough, that's brown.
I would love to do that for you, Nina.
Life is meaningless.
I don't wanna like really look
I still can't do passes all the way through.
You went down and struggled by
I know, normally we should have done together.
Yeah.
And then we just complain, and then she's like, you really do struggling.
Every time I go on one, I
Yeah.
There you go.
Yeah, right.
Mine tastes different than hers, like.
Ladies and gentlemen, people are still working. Please turn to page 19 and get started on page 19.
Oh, no, they're not.
What?
Ladies and gentlemen, please be quiet. Turn to page 19.
Well, I think what you're saying, man.
Oh yeah, I forgot. Isn't it you just like divide by 4 for everything? Is that how you do it? I don't know.
Take out a GCF.
Is that it?
Yeah.
You find it easy, yeah.
Yeah.
Don't you just completely forget about it?
So would it be x squared? Oh, and then you have to put it back later, right?
No, it just stays up there.
Huh?
Yo, cabbage, what's that?
Alright, so the first problem up here, we have 4x squared minus 4. So Ethan, you said divide by
4.
4. So they all have a 4 in common. That's the GCF, so that gets written outside. And then when you take a 4 out, whatever's left goes inside. So Ethan, if you divide by 4,
It'd be x squared minus 1.
you get x squared minus 1.
Yeah.
So then you need to ask yourself, can it be factored further? So can x squared minus 1 be factored? Does it match a way that we've talked about with factoring?
I think so.
Yes, it can be factored further.
Yeah.
So this is that special pattern. It's a perfect square binomial because I can take the square root of x squared. We can take the square root of 1. 1 times 1 is just 1. So how does that factor then? Libby? Right, so x plus 1, x minus 1. So when you have a perfect square binomial, you can factor that with 2 parentheses, one being a positive, one being the negative. Because when you FOIL them, that's how you get back to that minus sign in the with that minus 1. So take out a 4, and then whatever's left, can you factor it further? And if so, make sure to continue to do that. Letter B, we have negative 3y squared minus 18y. Savannah, what could we take out of letter B? Good. So negative 3y, and then what do you have left? Perfect. So this is just y minus 6. It no longer has, how about y plus 6?
Yeah, I was gonna say.
Oh, yeah, I was a little.
It doesn't have the little squared term with it. There is no other factoring. It's just the y plus 6. So you're done with that problem. You can't do anything else with that one. Scott, how about letter C?
I wasn't sure what to do with the rest of it, but I got x minus 6 and x minus 4.
Well, what could you take out? So what do you notice that they have in common?
Take out negative 2.
Yeah, so they're all divisible by 2. Anytime there's a GCF, we need to take that part out first, which we didn't really have a lot of problems that had GCFs in them all of last week. So if you take out a negative 2, Scott, what do you have left?
2m squared plus 5m, and then minus 12.
Good. And that one, we actually have to stop because we haven't factored anything with a number in front of m yet. So stop, keep it with the negative 2, you're done, nothing else to do for the problem. And then the last one, number 5, we have 5z squared minus 25z plus 40. So Kate, what can we take out of letter D? A 5, and when you take a 5 out, what do you have left?
Z squared minus 5z plus 3.
So this one doesn't have a number in front. These look like the problems we factored last week. But if you're looking at 8, 1 times 8 makes 8, 2 times 4 makes 8. Is there any way we can get a negative 5 with either of those? No. So this doesn't factor any further either, because if you have an 8, there's no way you can get a negative 5 from the multiples of 8. So the letter C we couldn't factor any further because we haven't dealt with the number in front of the variable squared. Letter D doesn't factor because it's not factorable besides taking out the negative or the positive 5. Questions? So we are going to start factoring today using the AC grouping method. Some of you may be more familiar with it than others, and it just depends who you had last year and how much they prioritized with the AC grouping method. So some of you may never have done it, or maybe you saw just a little bit but not enough to really thoroughly remember. So we are going to go through it together. Like you'll all pick up on it, it'll be fine. We'll see a whole bunch of problems, but a couple of you might have a little edge over others depending who you had. And I know if you have Mr. Warnock, he definitely likes factoring. So it really just depends on the math teacher that you have. And it's okay if you don't remember, no biggie, because we're going to go through a lot of problems. So it really is the AC grouping method because we're going to be multiplying but grouping things together as well. And it's step by step. So there are really 3 steps that we're going to be looking at. The last step is just a FOIL, and that's totally your option. You can always FOIL anything to check to make sure it works. But the first step is to multiply A times C, which is kind of what we were doing last week. But last week we were just looking at the C. Now if there's an A in front, we need to make sure that we're including that in the problem. So when you take A times C, it's the first and the last number, you get 30. Because that first number now affects the factors of the problem. It affects the answer. So the second step, find the factors of the product of AC. Well, we want to know what numbers make 30 that add up to be the middle number. That part isn't changing either. That's pretty much what we focused on last week. So if we have 30, Cooper, what 2 numbers multiply to be 30 but add to be 17? Negative 15 and negative 2 multiply to be positive 30, but add to be a negative 17. So here's where it changes. You can't just take these 2 numbers and put negative 15 and negative 2 in the parentheses. Because if you FOIL that, it's nowhere near 5x squared minus 17x plus 6. So that is not a way to factor. That's what we did last week, and it works if it's just x squared. Does anybody remember who's seen it before, what you do with these 2 factors?
Oh,
Nina.
you put 5x squared minus 15x minus 2x plus 6.
Alright, so just to kind of see what she did. This is called expanding the problem. So we currently have 5x squared minus 17x plus 6. Using the factors, you're going to replace the 17x. So 17x isn't physically written in the problem. But if you write both of these factors with an x, and you combine 15x and 2x, what do they make? Negative 17x. So it's still there, it's just written a little differently. So we kind of expanded the problem using the 2 factors that we chose. So you're taking those 2 factors, you're writing them in the problem. The 5x squared, the 6 never change. Your A and the C stay the same. It's just the 2 factors that you use to get there. So to factor by grouping, I'm going to put a little line down the middle. Grouping means you're going to take 2 things, put them together, and try and figure out what they have in common. And it's always the first 2 versus the last 2, so you don't have to rearrange the problem. So the little line down the middle is just a separation line. You don't have to draw it. But visually it helps you separate the first 2 terms and the last 2 terms. Feel free to put it in there. So if you look at just the first 2 terms here, what do 5x squared and negative 15x have in common, Julia? Of 5x. So factor by grouping is really taking the GCF out of the 2 pieces that are in the front. And Julia, if you take that out, what do you end up? Yeah, you get x minus 3. So you're taking the GCF out, you get x minus 3. Looking at the back 2 pieces, Julia, negative 2x plus 6.
Just a 2.
So she said just a 2, which are really close. What goes with that 2? Yeah, a negative goes with it. whatever this first term is, if it's positive, you need to have a positive there. If it's negative, you have to have a negative there. So when you're factoring that first number, if it's negative, you need to pull the negative out. And Julia, if you take a negative 2 out, what do you get?
Then x plus 3.
You get an x minus 3.
Both exponents.
So for factor by grouping to work, these parentheses, the x minus 3, has to be the same. If they're not, then you can't use factor by grouping. So whatever you're pulling out, whatever they have in common that you're taking out, must create 2 parentheses that are the same or equal. The reason we have to do that is because we're not done with the grouping part. So we're going to take the numbers in front of the parentheses. So 5x and negative 2. They are like terms because they both are attached to an x minus 3. So we can take these 2 pieces and literally pull them together. Of course, mine doesn't want to pull together. Well, if I could pull them together, I'm not sure why it's not working right now. All right, kind of. I lost my minus sign.
So what sign?
Minus.
Or minus. They said modest.
Oh, my minus sign, no. So I want to pull them together and put them in one parenthesis. So we're going to see if we can get these pulled together. Just get rid of this guy here. So I'm going to take the 5x and the minus 2 and group them together
I remember doing this one. I don't.
in a parenthesis. We can do that because they were both being multiplied by the same thing. And then the second set, which is the same parenthesis,
X minus 3.
is x minus 3.
Is it plus?
It stays as is. So there are 2 of these that are x minus 3. They're just going to get grouped together as one set, x minus 3. I don't write it twice because the separate 5x minus 2 was separate as each having their own. But if they're together in a parenthesis, then these need to come together as a parenthesis as well. And when you're factoring, we should have 2 sets of parentheses. And now we have that 2 sets of parentheses. So we have the 5x minus 2 and the x minus 3. And if you did FOIL, you'd get the 5x squared. Here's 15x, here's negative 2x, and then that positive 6. So it's the same steps each time, which really, I guess it's like a 3-step process. Questions? So if you flip to the next page, we're going to practice. There's 6 problems that are like that, and then there are a couple of problems that are different at the bottom of the page. We're just going to kind of practice through these. The first 3 that start off here are all positive, so you don't have to worry about changing signs. Every sign is positive, so when you're factoring, you'll have pluses in the entire problem. So you're going to multiply 2 times 7, which is 14. And we want the numbers that multiply to be 14 but add to be 9. So Chelsea, the 2 numbers that multiply to be 14 but add to be 9 are?
2 and 7.
2 and 7. So how would we write it down then, Chelsea?
2x squared plus 2x plus 7x plus 7.
When you're writing your factors in that expanded form, make sure the ones that have something in common are written next to each other. So she gave me a 2 and a 7. I want to make sure that the 2 is with the 2, the 7 is with the 7, because we're pulling out what they have in common. So when you're writing those factors, kind of take notice to how you're writing them so that they are grouped with something that has pieces that have something in common. So Chelsea, if we put that line down the middle, what do the first 2 have in common?
2x.
A 2x, and then when you take 2x out, you get?
X plus 1.
And then the second set have what in common?
7.
A 7. Is it a positive 7 or a negative 7?
Positive.
A positive. You need to place that plus sign with the 7.
Oh, yeah.
Because if you don't have that plus sign, then I have a problem that all of a sudden is multiplication. And I'm now multiplying 2x, x plus 1, 7, and x plus 1 together, which does not equal the previous thing. Math needs to be equivalent. Every step has to be equal to the previous. So make sure that you have a plus in front of that 7 because it keeps it equivalent or the same to what's before it. Ethan.
Are the parentheses always going to be the same?
They will always be the same. If they're not, then you didn't pick the right 2 numbers, the combination. So then your final answer, pulling the 2x and the 7 together, and then the parentheses were the same, so we can write those together as well. But they must be the same. If they're different, then you can't group them together. It means you didn't factor it correctly if they're different. Questions? So same step for letter B. Isabella, we have 3 times 5, which is 15. What makes 8? 5 and 3. So when we write them down, we have a 3x squared. I'm going to write the 3 factor second because 3 and 3 have something in common. So 3x squared plus 3x. And then I'm going to write my 5x and then the plus 5. And again, I'm doing that so that I have the same terms together. So my 3's are together, my 5's are together. The pieces that are similar that have a GCF in common, I want to put together. So Isabella, if we put a line down the middle, 3x squared and 3x have what in common?
3x.
Good. And when you take that out, what do you have left? Good. And then what's the second pair have in common?
5.
Okay. It's a positive 5, and you also have what in parentheses? Good. So then your final answer, we have the 3x and the 5 outside. So 3x plus 5, and then the x plus 1. Questions? So the third one, we have 20. So Savannah, what makes 20? That gives us 12. Good. 10 and 2. So 5x squared, putting the 10 with the 5 because they both have a GCF pair. And then the 2 and the 4 can get written next to each other. Again, they both have that GCF in common. So Savannah, what will we take out of the first 2?
5x.
And what do you have inside?
X plus 2.
Good. And then the second 2?
You take out a 2, and it's x plus 2.
Good. So check your parentheses, make sure they're the same. We get 5x plus 2 and x plus 2. Any questions when they're all positive? So see if you can work through the next 3 problems.
Oh, you know I can.
The signs change, just make sure you're paying attention to the change in the signs. But the factoring process doesn't.
No, we're left.
So multiply a times c, see if you can get it equal to a negative 1.
Focus on
Not, I don't do that. I wasted way too much money. I forgot to get clean up.
You like factoring too.
I do,
You
that's my
can't-
favorite part.
Bummer. You're not able to factor all these
I know,
problems.
you know, you live your factor sister.
Ethan, do you want to be my factor sister?
If I was a girl, yeah, but I'm not.
Do you want to be my factor?
Unfortunately, you can ask Asia, Jessica, there's plenty of girls in the room that can be factors.
Do you want to be my factor sister? You know, you're really replacing me in front of me right now.
No, I could never replace you.
Why are you crying? I'm just laughing. It's like starting to like every time I laugh now, I just start crying because of this.
Sorry, I can't be associated with soft people, so I don't know if we can be best friends anymore. Cooper.
Ethan, what numbers are you picking to make a negative 6?
I choose -3 and 3. But
Negative 3
that's-
and
I mean 2, sorry.
2. There you go. That's right.
That's
I
so
apologize.
proud of you.
So 3x
So
squared.
it's x squared minus, or 3x squared minus 3x plus 2 minus 2.
Good.
Oh my god. I mean 2x minus.
Yeah, I got you. So again, try and put the numbers that have GCF in common next to each other. So Ethan, you would take out a
I'd take us out of 3x and I would get x minus 1.
Good.
And then I would take out 2 and it would be 2 and then x minus 1.
Good.
And then I would do 3x parentheses 3x plus 2 parentheses x minus 1
Good.
parentheses.
Any questions with the first one? So Dylan H, if we have a negative 20 for the second one, what multiplies to this negative 8?
Negative 10 and 2.
So when you're writing that, which would you put first with the 4x squared?
2x.
And then the 10x. And then the minus 5. And what would you pull out of 4x squared minus 2 or plus 2x?
2x.
And what do you have left?
2x plus 1.
And then the second set,
Negative 5.
and you also have
2x plus 1.
awesome. So your answer, we have a 2x and a minus 5. And then the parenthesis is 2x plus 1. Any questions with that one? So the GCF doesn't always have to be all of the first number. In that case, you were just taking a 2 out because that's all the 4 and the 2 have in common.
This is
So-
actually easier than I remember doing.
The last one here in this group, we have a negative 18. Josh K, what did you get with negative 18?
I got negative 6 and 3.
You're so close.
Oh,
Yeah, negative 3. So positive 6 minus 3. So 2x squared plus 6x minus 3x minus 9. Josh, what would 2x squared and 6x have in common?
2x.
And then what do you have in the parentheses?
X plus 3.
And then the next one, what do they have in common?
Negative 3.
And in your parentheses?
X plus 3.
So 2x minus 3 and x plus 3. So questions on those 6. We've now gone through 7 of them. We got a little quicker as we were working through. The last 4 are a little different. They don't really fit to the 7 that we just went through. The first direction wants you to take out what they have in common. So take out a GCF.
I did do a lot, yes.
And Cooper noticed that it's missing, like this one's missing something. It just has an x squared and then the 16. So it doesn't really fit that AC with the B in the middle. So we've got 36x squared minus 16. What do they have in common? Start with that because it says factor out a GCF first. Josh?
4.
So if you divide them by 4, Josh, what do you have left?
9x squared minus 4.
Good. So 9x squared minus 4.
Alright.
So this is a 2-term 9x squared minus 4. Those numbers have something in common because they are both what types of numbers? Perfect squares. So 9 is a perfect square, 4 is a perfect square. And when they're perfect squares, we can factor them using that perfect square pattern. So this fits the pattern. Does anybody know what they would look like when they go in the parentheses?
No.
X minus x plus 3.
Okay, so Ethan, let's look at the first number. It's 9x squared. What's the square root of 9x squared?
Oh, 9x, dog. I mean, wait, right? Isn't that? How?
What's the square root of 9?
Well, I mean 3, but I thought if it's 9x times 9x. Oh, it's only the x that's squared, so it's 3x squared.
Okay, so it's just going to be 3x.
So 3x, that's what I'm saying.
What's the square root of 4?
2.
2. So we're going to write that as 3x plus 2. What goes in the second parenthesis then?
Something with a 4, I'm guessing.
No. 3x minus
Is it
2.
a minus 2?
3x minus 2.
Oh.
So if you FOIL this is a perfect square binomial pattern. If I have 3 times 3, I get 9x squared, and then 6x and a negative 6x cancel, and then I have the 2 and the negative 2 to give me negative 4. Don't forget to bring that GCF down and write it in the front. So this is that A minus B, or A plus B, A minus B pattern. So it's still that same pattern, but now there's a number in front of x squared. So take the square root of the first number, take the square root of the second number. So if you look at letter B, we have 9y squared plus 42y plus 9, or 49. So what do they have in common? Do they have anything in common? I guess I should say. No. So they have nothing in common, but what do you notice about the first number and the last number? Brandon? They're perfect squares. So this is the perfect square pattern that says A plus B quantity squared. So this was the pattern that we've worked with, but now where the numbers are getting a little bigger. So Brandon, what's the square root of 9y squared? 3y. And the square root of 49 is 7. So we would factor this as 3y plus 7 and then squared because it fits the special pattern. So these are special pattern questions, not your typical AC grouping questions. So look at letter C. First question, what do they have in common? So 15p squared plus 24p minus 6.
3.
A 3? So if we take out a 3,
You get 5.
you get 5p squared minus,
Is it 8? I think?
minus,
Oh, 2.
2.
Oh.
thank you, sorry. So 5p squared plus 8p minus 2. So if we check with AC grouping, the next step would be to take 5 times negative 2, which is negative 10. 2 and 7 or 10 and 1? Will they ever equal 8?
2 and 7.
How about 2 and 5? I don't know how I got 7.
It still doesn't.
So this doesn't work. This one is done. It does not factor any further. So you only take a 3 out. The last one is the other perfect square pattern is a minus b squared instead of a plus b squared. All right, so I'd like somebody to do 33 and 45 tomorrow.
I'll do 33.
You have 2 already.
I have 3.
Yeah.
I did.
Asia?
I did my, Miss Kate, did I do my 2 already?
Yeah, you did. You definitely did.
I think I did.
Yes. So Asia, 33.
You ready to fall asleep and study for this stuff?
Thank you, Savannah. Savannah, 45.
No.
Thank you.
God,